Welcome back guys, I am Himanshu and this is the chapter 2 of Star Agile's DevOps learning series. Today we'll be talking about SDLC and DevOps culture. Before we dive in, please make sure you subscribe to our channel and hit the notification bell so that you don't miss any of our future updates. If you have missed covering the previous episode, you can click the link above. If you want to learn DevOps and get globally recognized certificate, you can take our DevOps certification course. The link is given below in the description box. Alright, let's start the chapter now. Alright, so let's talk about what is SDLC, software development lifecycle. This is a very common term when you heard in terms of in the area of DevOps. It's very commonly being used. So you should have understanding about what is SDLC. Basically, this is explaining a software, how does a software is being deployed, how does a software is being published to their consumers. So there is a life cycle which is used in the IT industry in terms of DevOps. When I say so, DevOps uses that, and the advantages of DevOps are being implemented in this software development life cycle. We will see the step-by-step process, what it actually does. Okay, so let's say, for example, there is this circle. I explain it like this. Okay, so the first phase is the planning phase. Okay, when the planning happens, we will explain, we'll see what each phases does and what is the significance of each phases. So there is a first phase called planning, then there is something called defining. Okay, then they call designing. Okay, okay, after that building. Okay, then testing. Okay, and then deployment. Okay, now first we will see why do we need SDLC? Why do we need software development lifecycle? How do we, why do we need that? So think like another example, any e-commerce website, let's say flipkart.com, or in our case, let's say we have example.com. Okay. So example.com so far has catalogs for category, let's say men, okay, and women. So these two categories are present, but there is a new requirement for our consumers to have a kids sections, to have a kids catalog. Okay, so in that scenario, you can have a new catalog called kids catalog. So that kids catalog can have variety of things, variety of products which are available for the kids. So this requirement is there because our consumers wants, okay, you basically sell a good products and you basically sell for men and female, but then we also would want to buy for the kids section. So you should have a catalog called kids catalog. Okay, so in this phase, the very first phase called planning, which means the big people of a company, the senior directors, the managers who basically design, who basically define the priority or the plan. Okay, the product owners, basically I would say, who basically handles okay, this is the new product which is being handled. Product manager has defined, okay, I would want to implement kit section also. So he will have a meeting with board of members and stuff like those, which are relevant to that product area. So that planning is being done. If they are not suitable, they found any of the members found, or there is an argument discussing about why do we need this, why can't we have it without this, and what is the requirement. They might be discussing in terms of the money wise, in terms of the revenue generation for that catalogs and stuff. They discuss all these things in the planning phase itself. If that plan does not really works well, they terminate the plan itself, where there is no point of discussing all these SDLC. But we are thinking about a scenario where such things think like, the planning phase is going well, where they are defining things, where they are understanding, oh, we have a requirement, our customer is also requested that, our customer has provided feedbacks in terms of that they really would want to have a kids catalog in our website, and we should definitely release that feature as well in our new version. Okay, so let's say that planning phase is completed, by the product owner. Now that phase from the planning goes to defining state. So when I say defining, that means is you are documenting things. So defining, you can just think like documentation. Then this thing is documented. Everything, every single meeting, every single discussion about this new plan, they will be documenting it. Why are they documenting it? So that it's easy to readable, accessible and understandable, in that sense, okay, why this catalog was even planned. Because there was a requirement from the customers, there was a feedback from the customers. That's why we had this requirement, and they discussed this in the plan phase. Now they are basically defining what do we need for that, So how much revenue it will generate, how many customers are being affected by this, how many customers have provided feedback to us, how many new customers we see have scope in this sense where they can implement those features and stuff. So everything like this will be going into the defining phase. Okay, which means they are basically documenting all set of their discussions and their plannings and stuff. So once that is done, after that this life cycle goes to designing phase. Okay, so now there are two types of designing. Okay, so this designing has high level designing and low level designing, HLD and LLD. You must have heard about this term HLD or LLD. Don't get confused, even SDLC also. So it's software development lifecycle, where we're discussing about the software which will be released, why is it released, what are the lifecycle it follows. Then in HLD means the high level design. High level design means the architect level of people or the engineers who basically design the product. Okay, for this, what do we need? For kit section, they must be high level, like, okay, we need this setup, we need this website, we need this payment gateways and stuff, those things basically. So they define this high level of designing. And then low level designings are the ones basically engineers who basically each and every small items which are required for this catalog to be published to the consumers, they must be like, for example, we need to make changes in the Nginx, they note down that one. After that, we need integration to the payment service, they note down that one also. After that, we have 10,000 or 10K category of our product, so they note down that also. We would need to make changes in our API, they note down what is the rate limit that this product can support or this catalog can support further. So each and everything, small things, they will be noting it down, so that it's easy for the developer to develop it, to build it, so that the developer will write the code according to that fashion. So after that, anything they can mention about which database we will be using. We would need this particular database or some other database, or how are we integrating this page to the men's catalog or women's catalogs. So they will be discussing and they will be adding those points in the low level designing. So any changes in the current product, and any sort of services or any sort of tools which are required, they'll mention each and everything in the low level designing phase. After that, let's say for example, if the designing is also completed, then it will go to the building phase. Building phase is to build the product, build the code, basically the code. So who will build the code? Who will write the code? Developers. So developers are the ones of the company who are responsible to build that code, to write that code. Okay, so they basically start building the code. Now this code building is done. After that, let's say the code is ready, then code goes to the testing team. They do unit test, distributed tests, and whatever the tests are available in this market at this moment. They start testing all these things on the product code. Okay, all the testing is done. Once the testing is done, after that they do the deployments. Okay, deploying on the servers, releasing on the servers. In terms of, in the form of release, they call it release. The build is getting released in the new features, so they name it. Actually, they tag this. Okay, we have a new catalog coming for the kids, which will be inclusive of release 1.2 or 2.5 or whatever the build release was happening. It could be a monthly release, or it could be a weekly release, or bi-weekly release, or whatever, right? So they name or they tag that release in terms of deployment, and after that this deployment product is ready for the consumers to see. Oh, now the kids catalog is being available to the users, they can use it, the software is ready to use, and any issues which comes up now and then will be rectified or will be reviewed internally to the by the engineers, or if there is any bug, so later they can tweak down things, they can further trim it, they can further work on it. But for this is the initial things from the planning phase till the deployment phase. This is how a software is being written or designed and developed and then pushed to the production environment. Now you must be thinking, where is, in all this planning, where is the DevOps come? What is the role of DevOps? Why do we need this in all these things? When these things is there already, then why do we need DevOps? So DevOps major role in last three phases, building phase, okay, testing phase, and deploying phase. So these are the three phases where the DevOps plays the major role. How? They can automate this building process. How can they do it? They can use centralized repositories where they can implement Jenkins CI/CD or GitHub Actions and whatnot, right, to make this build faster. Then on the fly, they can do perform testing via any testing tool which are available for respective code which is written in Java or some other language, or Go language, or some other language, right? So they create that testing environment so that it's easy for the tester to test it on the fly itself, so that it should not take much time and there is no silos. Everybody can see whatever is happening on the testing phase and how the product, this build is basically going to release, and how does it going to look like. So then they can make these things automated as well. Later in the deployment also, they can make it easy in terms of configuration changes which are going to happen, so they can implement a configuration management tool, Ansible, or any other tool, SaltStack or something, right? So which can help the configurations to publish on various servers. The load balancers, a set of servers where it's responsible for the consumers to see, okay, this is my website which is basically running on this one. So these three stages are the ones where the DevOps engineer plays a major role to make this process faster. See, planning phase, nobody can do anything. DevOps cannot help in planning because that is being done by the product owners. The ones who are going to decide the management, business revenues. They are the people who basically, sales engineers comes into pictures, and then they suggest, oh, my customer is basically requesting this. We should also implement such features in our product. So those planning has happened in the product side of the house, where the product owner basically decides, are we really sure that we would want to publish this product in our portfolio? Because later, if some issue comes up also, the issues will go to the support engineers as well to support that product as well. So they should be pretty sure or clear in that terms itself before proceeding further in the software development lifecycle. After that, defining in the documentations way. Later, if somebody refers to those phases and see why this was even planned, oh, there was a requirement, or there was understanding that business can grow, revenue can generate more. So that's why this was planned, and then everything is documented. People can see it later also. Then designing, they have a proper designing. Let's say if somebody is using AWS, so they have a designing about VPC of AWS, then networking components, then API components, and whatever the automation components. So everything they basically mention about on this port, we'll be listing this service, and then it'll be easily recoverable by the consumers via external access and stuff, so and so stuff, right? Then it'll be like slowly built. So later, if let's say something happens in this issue, in this product, let's say they release version 0.1, okay, and there are some issues which they identified after releasing when users started consuming it. Now they target to version 0.2. So this thing is already done. There is no need of all this. So now everything will be again recover from the building to the deployment phase, where the developer will rectify those bugs. They will make code change, they will remove something, they will add in their code in the centralized repositories. With the help of DevOps, they do real-time testing in order to see how does this code performs and how will it be feasible for the users to use it. Will it not crash this time, or will it not create some more issues and stuff? So they make sure all these things test has to be passed before it is going to publish to the production environment, and then it will be deployed to the production environment. So that is all about the software development lifecycle. So to achieve this, we will be seeing in our upcoming sessions, where we'll be discussing about the tools, the CI/CD tools, GitHub Actions. We'll be seeing Jenkins, how do you deploy the S3 buckets to copy. So those things at a level you should have an understanding. How does the Terraform being used here by the DevOps engineers? We'll be seeing all these things in our coming lectures after this. So this is all about the software development lifecycle. So if somebody asks you, should not get confused by this term called SDLC. It's a software development lifecycle where a product changes, how does it being published or pushed to the consumers. You should have this understanding that there are phases. It should go from the planning phase to the defining phase to the designing phase, and then building and testing and then deploying. So all these phases are basically being called. And if there is some in the SDLC process, that's how the DevOps basically involves themselves in order to make it more improvised, more faster, and resilience provided to the customer. So that's how they can help to build it and to test it and then deploy it later. All right. So now let's talk about the mindset and the culture transformation of the DevOps. So basically, if somebody asks you DevOps, it's not just about the tool, it's about the cultural shift that they would want to implement. What it can help in order to do that cultural shift. If we see what culture it can bring, so it can focus on the collaboration part, okay. Right. Then shared responsibilities. Okay, and then continuous improvement. All right, so these are the three things which are mainly important for DevOps. So they help to collaborate between multiple teams. There are no more silos. Okay, testing team is doing what, and then build and release team is doing what, or observability team is doing what. So they have this process or alignment where they collaborate much easier and much reliable and much more focused towards multiple teams which are being involved inside that collaboration. Then they also have a shared responsibility. So it's not just the responsibility for the developer who developed the code and then give it back, just to publish it or release it. So DevOps holds there, they can control those responsibilities where, let's say, something happens during the deployment phase, So the DevOps engineers are so much capable that they can handle their code themselves and try to understand, there might be some settings change which was there previously, but it is not there. So they are able to rectify those. So they have this process where it can help to identify the problems much faster. Okay, so they have this responsibility to identify, to understand this. Yes, if so detail of the code engineer is required, then they can call that engineer on the while they're deploying or release day, when they are going to release the product of any launch. So otherwise they basically can tweak things by their own, and they understand the set of code and the integrations within multiple components which are running in the company. So they own that responsibilities. And also the continuous improvement, so it's not just that one side, one way. Okay, the process can help. Okay, once the product is launched, after that done. No, it's not like that. It's always about the continuous improvement, how better you can make your process next time. So let's say first time a DevOps engineer is releasing something on the release day. They took 8 hours of time, multiple services were upgraded, and they implemented those things. And later they always focus towards how can we reduce this 8 hours of release time to further 6 hours or 7 hours or 5.5 hours. How they can do that, if there is any tool which can help them to achieve this, or there is some other process that they can align. So they always talk about the cultural shift, how they talk about the mentality. Okay, we would want this to happen, release to happen, but to our way, because we own that building, releasing and testing phase, right? So they can do it a more easier way. What else could be done parallelly, so that it can overall reduce the time of deployment for any product? So that's how they can help to improve the release process or deployment process continuously, so they can work towards that. So it's always about improvisation with the time. So that is all the responsibility and the cultural in terms of DevOps mindset. And if we talk about other things, so they basically remove silos. So there are no more silos, okay, earlier which was there, because silos means like some isolated mentality of engineers who basically have been worked. Let's say developer has some silos created in their own team, where they are working something and nobody is aware about what they are working. So DevOps engineers always have integrity or close collaboration. Okay, you are working about this feature, it will be going live next month or next week. We should be ready with all these processes, which are basically easy and really important for our product to launch, right? So they basically remove that silos which was there previously in the team, used to share the code to the build and release engineer, and then later to publish it to the server. So they remove this silo. So this mindset can help to remove silos. And then continuous improvement that we have seen. So these are the two things. And also if we talk about the examples, right? So let's say Netflix. So Netflix basically, they perform chaos engineering, where chaos engineering means intentionally they try to break their product. Actually they implement those changes which can break their product, or they implement certain things which can help to improvise things. So they basically implement those things intentionally, so that their website netflix.com, whatever they serve to the customers, should be always having best experience to the customers. That's why they are paying so much money, right? So it's always about the customer experience when it comes in terms of business revenue generation, right? So it's always about the customer. What do you give it to your customer? What your customers get satisfaction or experience based on the product that individual service provides to them, right? So every set of team, different cultures, they try to implement those things. They try to focus towards, okay, let's implement this chaos engineering, where they can break things, rectify it while breaking itself, and then resolve it before it goes to the customer, and then later they do a reactive job rather than being proactive. So if we talk about the transformational change that has happened with the traditional approach and with the DevOps mindset, so those approaches are, let's say, earlier DevOps developers used to hand off the code to the deployment engineers to deploy it. Okay, but now in that traditional things have gone back. In this, basically developers work with the DevOps engineers throughout the cycle in order to publish this code, so they can work together with the operations. Earlier they used to push this to the operation, and then operational engineers used to work it towards deploying it. All right. Now there was lot of manual process involvement was there, but now everything is automated. So you don't have to do any manual intervention. If any settings or anything which is required in order to change to product to launch, those, so they can set up any automation jobs or a automation script that can help to do it on the fly itself, so that no manual intervention is needed. Then they basically, earlier it used to be like a reactive problem solving, but now it is proactive. Okay, proactive means like implementing chaos engineering, as I mentioned in the netflix.com, where they implement intentionally want to break product, and if something breaks out, they fix it before releasing to the customers. So that's how they can help to build. All right, now let's talk about collaboration. How can collaboration between development and the operations can evolve the process, this make it much better. So let's talk about that. If we see how does this collaboration, so it basically improves the communication. Okay, improves the communication between multiple teams. Then they can do faster problem solving. See why? Because if you do more and more communications between teams, there might be chances that different minds have their different ideas and different way of solving problems. So those ideas are being shared now. Earlier, which was not there, which was like purely silos teams. But now everything is across, like there's a bridge of DevOps, which they are helping other teams to open up, share their ideas, to break things, and then to fix it before anything happens outside the company. Should not be a good thing for the company. Whatever happens within the company, they fix it, they provide the best experience to their customers. What is very important, right? So they can sort out the problems very fast in order to make it more communicated with various teams. Then they can perform innovation, so they can do better innovations also. Okay, and then after that, their practice, they can use shared tools. So shared tooling, let's say Jira, then all Confluence tools are there, then Scrum Master, Agile. So those are the things which are being used in the DevOps culture, where they try to make it more shareable things. It's not just the silos, it's all about sharing and collaborating with other teams, so that people are aware and they can help you, they can guide you, they can suggest you in order to, as a team, they work and then they try to build a better product. I would say, if Google, for example, let's say Google or Amazon or Netflix, these are the very big giants company. Or if we talk about startups, PhonePe or Paytm or Zomato, Swiggy. So these are having a good DevOps engineers, where they have a good collaborative way of approach, where multiple teams collaborate their ideas, they try to fix it, so that their end users, their consumers, get the best understanding, their best experience in terms of using their products. That's why they are basically dependent on those engineers who basically collaborate more. So if there are teams which does not collaborate with each other, it's very hard to find out and publish things. It takes time also. But if you really want faster resolutions to happen, if you really want a proactive approach, if you really want a better mindset with the collaboration strategies, that's where the DevOps, the process, this culture helps to build a good product actually. All right, so this practice to foster the collaboration can also help blameless postmortems. So for example, there is some issue comes after all these release cycles and stuff, but now they would want to see what happened after that issue. They would want to do a postmortem after this. So every team, whosoever was involved, they can just jump on a call, they can create a war room where they can discuss about what went wrong actually. They would want to try out, this could have been done by this way, or the issue has occurred because of this. They try to find out the RCA for that, and then such issues should not happen in the future. They try to rectify those things. So with the collaboration of multiple teams, this basically the collaboration activity, the mindset of a DevOps engineer can help to debug the issues. They can help to do the faster postmortem for any issues. They can try to find out the root cause so that they can rectify it quickly and next time should not happen. All right. After this, there are some other practices that DevOps does. One of those practices is Agile. You must have heard about this term called Agile, Scrum Masters and stuff. So this process is nothing but like all these Confluence tools like Jira, Wiki. So they have this something called sprints. Sprints are some companies, they do sprints for 3 weeks. Some companies have a sprint for one month or 2 weeks or such that. So this sprints is for those developers or the engineers who basically develop things, or they have the projects assigned. So during that sprint cycle, they basically perform their tickets. They take it. The ticket is like visible to other engineers, also visible to the product owners also. That okay, so they have a targets assigned. Okay, for 4 weeks down the line, we'll be deploying this phase of this launch. 2 months down the line, we'll be having second phase or third phase launched, and we'll be having a GA or private preview or public previews, things like that. So this is sprint wise they work basically, and they also have story points on those sprint. Let's say one Jira is one story point, so you have to achieve via performing 10 story points in 2 weeks or 3 weeks, so something like that. They have some criteria thresholds to identify okay how much an engineer is working, how much effort he or she is doing, so they can track down those activities also. And also they have a daily stand-up calls where they discuss about these are the blockages which are coming while developing these features, or they everybody basically discuss in a team meeting where they talk about okay, we'll be working on this feature towards by end of this day, I'll be working towards this, and how can we integrate. There will be some other tickets which are needed, or they basically try to unblock everybody on a day-to-day basis, also get some idea about whatever is going to happen today. So every day, that's how they set up stand-up calls, and then they take it forward. So that's how they work actually in the agile manner. So basically they use Scrum and Kanban. So you can just note down these terms which will be mainly used. So Kanban board is like a wiki board where they can track down on the dashboard, okay, who is working what and how many tickets will be closed in this sprint and how many stages will be completed of a particular project. So that Kanban board can cover it. And the process of having this stand-up calls and discussing in the sprints and story points is called Scrum. So that is all like Agile. Agile is a term where it's a process basically which helps to foster things faster and enhanced and more proactive rather than reactive works. Then ITIL also is being involved. If I talk about ITIL, so it's like there are two things which are there. One is change management, okay, and another one is the incident management. Change management and incident management. So any change which is going to happen, and there is a process after any ticket which are being there to in order to approve it, or approval process or whatever, they can implement and such of processes in the tickets, and they can track down okay, this change will be live on this date, or this will be approved by this engineer, or if let's say some director is missing or somebody else has ownership to approve those changes, they can approve the changes and they take it forward, then developer will push those changes further. So those are the things which will be managed through the change management. And then incident management is like whenever such incidents happen, some issues which comes up, so they will discuss about how do you manage those incidents, how do you take the proactive actions, or if something has happened, how do you identify incidents, create a war room, pull everybody in order to make sure recovery, do the better recovery, and quick as possible. How can you improvise and enhance things in terms of giving productivity and support to the end product goal. So in the change management and incident management also, it's another approach what DevOps engineers basically implement in the ITIL form. And then there is one thing called lean. Lean in DevOps is basically to improve the flows. Okay, lean is a term basically which improves the flows. So it has some principle like they value the streaming mapping. Okay. That means that they identify the bottleneck of a delivery process. If there is any bottlenecks, they try to rectify those things. So value stream mapping. Okay. Second one is the reduce waste. So this is another approach what basically DevOps implement, to make sure that to eliminate the repetitive task. If there is any task which are being repeatedly performed in order to publish any changes in the code or things like that, so they can avoid those tasks any repetitive manner, so that there should not be any wastage of time of engineers or things, so they can change that process. So all of these things are being part of the mindset what DevOps can give to the organizations, but the end goal is to make the process better, make the product launch very frequently with lesser number of bugs, or with mitigated issues and things like that. So that's how DevOps can help companies in order to build such processes inside, and then they can have a better customer experience and can generate a better revenue for the company. So that's all about the mindset we are talking here. That's a wrap for this chapter. I'll meet you in the next video of our DevOps series. Till then, keep learning.